Okay, so let's first briefly go over the quiz for regular expressions. What regular expression would match at least one x followed by 0 or one y followed by any number of z's? So x plus means at least one x. Y question mark means 0 or 1 y, and z star means 0 or more z's, any number of z's. And you surround it with the / indicating it's a regular expression in Perl. Of course, if it's a shell script, you don't have to, you don't need the /. If it's Perl, you need it. So what regular expression would match any number of star followed by any number of backslashes? So any number of any character is indicated by star following the character, but you want the actual star to be the character, so you need to escape it by placing a backslash in front of star, meaning that you want the actual literal character star repeated 0 or more times. That's the next star. And the character backslash repeated 0 or more times. So and also remember, you can replace the / as the separator with any other non-numeric and non-character, non-alphanumeric character. So you can use pound or @ or dash or anything to replace the / If you do that, then you don't need to escape the if you have / you don't have to escape it. So this is useful if you have, say, directory path names. Have a /user /bin /, and if you don't want to escape each one of the / you can use the say @ as the regular expression separator instead of /. So you can write the path without using the backslash to escape each one. So anyway, so what's the simplest way to describe what is matched by the regular expression above? It really matches anything, even the empty string, because empty string is just star repeated 0 times followed by backslash repeated 0 times. And also, this guy matches any string that has something before it and something after it. So this really doesn't say anything. This really can match anything. Even the blank line, empty string. So will regular expression match a line that contains bill twice? So all of these match. So there can be something in between the two bills. So simply bill dot star bill dot matches any character except the new line. Because new line is special. New line is used to separate strings. So therefore, regular expression always matches a single string. So dot matches anything except the new line. Star means that dot any number of characters except a new line. So this allows you to have anything in between to the two bills, except the new line. And also, you can have anything before and after these two bills. So A Bill, Gates Bill, Clinton will also match because dot star matches Gates. And then the whole value expression matches this one, Bill, Gates, Bill. And you can have anything before and after it. So you can have A before it and Clinton after it. How to write a substitution that deletes the first occurrence of string Bill in the default input, $_. If you don't specify anything, it is the input variable. So you say S substitute followed by the regular expression. Bill, replace it with null string. There's nothing in between the next two forward slashes. So essentially this is deleting the Bill string. And it deletes the first occurrence of string Bill. If you want to delete all occurrences of Bill, you need to have a G following the last forward slash, indicating global replacement. And also this thing, as with any regular expression, it works on a single string. That is a single line of input. If you have a file that you want to replace every single Bill in the entire file, you cannot do it with a single regular expression. You must surround it with a while loop, while angular brackets, and then substitute Bill // G. Then it will replace every line. You replace every single Bill and iterate over all lines. So this program is supposed to print out all lines that contain all 5 lowercase letters. So while bracket, this is the shorthand for reading in the input, reading in until the end of the file, reading in one line at a time. Where is it stored? Because you didn't specify the variable name. It is stored in $_, the default variable. And you have an if here, which means that you're matching this regular expression against $_. If you want to match it against some other string, you need to specify the string variable name equal tilde. Indicating a specific variable name. If you don't specify the variable name, it is matching against $_. So this guy is, and then print. Print what? Print $_. So this guy says this regular expression matches any one of A, E, I, O, U. Surrounded by angular brackets indicating any one of the 5, not all, right? Your match print lines that contain all 5 literal, all 5 characters. You need to say this. So you match this guy. So this is a single character A. So this matches any line, any string that contains letter A. And this E matches any string that contains letter E. And you use AND to put them together, meaning that you match this line, this string against A first. And if it matches, you look for a E. If it matches, look for a I. And only when all 5 match, that is, it contains all 5 of the characters A, E, I, O, U, then this whole thing returns true. Then you print this string, $_. If any one of them returns false, that is, if any one character is missing from the string, this whole thing returns false. So this is really matching 5 times. Of course, if anyone returns false, you can exit early to return false. But to match true, you must match all 5. What if the expression matches all lines that contain all 5 lowercase vowels in order? Intervening letters don't matter. So A ** E, which means that A followed by any number of any character followed by E, and so on. So this is more restrictive than the previous one. Now the order must be A, E, I, O, U, possibly separated by some other characters. What regular expression will match 7 or more x's followed by any 3 of any character followed by up to 4 z's. So x curly braces 7 comma, which means that 7 is the lower bound and the next one following the comma is the upper bound. You omit the upper bound, which means that you have 7 or more x's with no limit on how many. So followed by 3 of any character, dot curly braces 3. So dot is any character, and z, 0 to 4 z's, 0, 4. What expression would match a string letter followed ending in a digit? So letter \d, which is a shorthand notation for any digit 0 to 9. Or you can write 0-9. 0-9 means 0, 1, 2, 3, 4 until 9. And with square brackets, which means that pick any one out of the 10. Or explicitly, square brackets 0, 1, 2, 3, 4 until 9.
Actually, the answer I think is not correct because it said ending in a digit, but there may be something after the digit. It also match.
Well, that's right. It doesn't say that. Well, yeah, this is not very rigorous. Letter ending in a digit. Yeah, that's true. You should have a $$ in the end if you want to say nothing after the digit. For this expression, you can have something after it. So this substitution, so you are looking for Bill followed by any number of any character followed by Gates, and substitute it with Mr. Bill. And you don't have a G after the /, therefore you're substituting the first occurrence of the first pattern. So you have the line here. Bill Clinton, after watching Bill Shakespeare in love with Mr. Biggs, is just garbage. So the key here is that dot star is it matches anything, so it'll match this whole thing from the space up to here, and then replace Bill a bunch of things and gates and replace it with Mr. Bill. So what an expression would match all lines that contain two consecutive vowels? So you can write explicitly AA, or the vertical line indicates choice. EE or II or OO. Or you can say pick any one of A, E, I, O, U indicated by the brackets, square brackets, and save it in memory. Parentheses stores it in memory because this is the first parenthesis. It is stored in \1 or $1. And then you retrieve it with the \1, which means that you repeat the character you saw before. So if you saw A before, you must have double A. If you saw I before, you must have double I. So what regular expression would match two consecutive characters that are not vowels? So not is hat within the square brackets, and it's not a vowel followed by itself. \1. So for this one, it's more difficult to write out the entire match because you have 21 non-vowels. If you want to write it like this one, you must repeat it 21 times. But this expression here is much more succinct. Also remember, a hat means something different if you have it outside of the square brackets. If it's outside, it means the start of the line, start of the string. If it's inside the square brackets, it means not. It means negation.
So does it mean that not A, E, I, O, U, that maybe 1, 2, 3, 4, 5 also will match it? Which means 2, 2 will also match a string.
Yeah, that's right.
So it's not character.
Yeah, that's right. It will match essentially anything, even a pound or any special character. So yeah, this is not very rigorous. So the following program is supposed to test if the line contains just the string Shakespeare, nothing else. What is wrong with it? So this is the reading in one line at a time and storing it in $_. You chunk with nothing, no argument, which means that you chunk the $_. And if this guy matches the regular expression, which is a simple string against $_, and print. So this guy will match any line that contains this string, but possibly with something before and after the string. If you want to say the line contains just the string itself with nothing before and after it, you must have hat and $. Hat indicating start of the line, $ indicating end of the line. So this guy will say it has Shakespeare as a string or in a single line with nothing before it and nothing after it. So the line starts with Shakespeare and ends with Shakespeare. And also, if you need a new line, you should say the new line explicitly. Or another way to do it is to say print, comma, and print new line. Where the expression would match a line that contains field twice, where only white space characters or a line and, that is the new line, appear before and after each field. So these three all match. This doesn't match because the second bill doesn't have a white space in front of it, and this guy doesn't match because the first bill doesn't have white space after it, and this guy doesn't match because the bill have an A in front of it and gates following it. So this is so backslash S means white space, which matches space, tab, and something else. New line. So this guy says either the following string is the start of the line, hat, or there's a space or a tab in front of the string. So say this example, the first bill would be the start, either is the start of the string. For this example, the first bill is not the start of the string. However, it has a white space in front of it, so it'll match backslash S. So this guy will allow both possibilities. So it'll permit either the string that starts with the bill, or it doesn't start with the bill, but the bill, first bill you'll see has a white space in front of it, or a tab. So the last part says either a white space or a dollar or the end. So it either ends with the bill, or the last bill you'll see, the second bill you'll see, is followed by a white space or tab. If it's followed by a new line, then it'll match backslash S and it'll match dollar. So either one will match. So look at this one in between. It says bill followed by any number of white space followed by a single white space, followed by any number of characters, followed by another white space, followed by bill. Or bill followed by white space, followed by bill. So this says you must have two bills, and you must have either a single white space or two white spaces, one after the first bill, the other before the next bill, with any number of characters, including white spaces in between the two white spaces. So the first bill, space bill, will match this one. While bill gates bill will match this one. So bill white space, gates matches dot star, white space bill. So right, any questions? The word expression would match all 5 characters, including new line, and any 5 characters. Say, you can say dot or new line, repeated 5 times. Or you can say simply curly braces 5, which is more succinct. So we have another quiz. Essentially, you can go through this yourself. It's not very difficult. Okay, so we move on to our next lecture on Perl directory access. You can change the current working directory in Perl is cd change directory. It's the shell command for change directory, but in Perl you need to do cd dir, which takes a single argument, the directory name to change to, and returns true if you've successfully changed to the requested directory and false if you could not. So this says change directory /etc or die. So if it's successful, it returns true, then you skip the die part. If it's false, then you go on and execute the die part. Parentheses are optional. So this Perl script /print where to go, you take in stdin, store it in where, and chomp it, and change directory to it. If it's successful, you print succeeded. Otherwise, you say not successful. If the directory doesn't exist or you don't have permission. So of course, if you don't omit the where, you can just directly do a chomp stdin, and then you can do a dir. Then this will also work because the default variable $_ will be used. So when your Perl program starts, the current working directory will be inherited from the shell that invoked it. Wherever you are in where you invoked the Perl script, it will be the working directory within Perl, within your session of running the Perl script. So you can change directory in Perl will not change the working directory of the shell where the program ends. Therefore, if you exit the Perl script, you'll be where you were before you invoked the Perl script. Any dir you do in the Perl script will not affect your working directory outside of the Perl script. So dir without any parameter defaults to take you to your home directory. So globbing, so star, the shell takes a star and turns it into a list of all the file names in the current directory. So if you say this, it turns into a list of all file names in the current directory that begin with a letter in the first half of the alphabet from A to M, and with .cpp. So expansion of star into the list of matching file names is called globbing. I don't know exactly why it's called that. It's just a convention. It's just the old term. So a single star matches all the file names in the current directory. If you say A star, it means any file that starts with the A. And if you say A-M square bracket star, it means any file that starts with any letter in the range from A to M. Notice that it's not a regular expression. Star in regular expression means the character repeated 0 or more times. But this is globbing. So this means anything that starts with A to M and with anything that follows it. So the star here really means dot star if you write regular expression. But this is globbing, therefore you don't have / surrounding it. So it is not regular expression. So you say, put the pattern between angle brackets for the glob function. So angular bracket star assigned to all this is the array variable with the @ in front of it. Dollar is scalar, @ is array. So @all will contain a list of all the file names in the current directory. Notice it's the angular brackets, not /. Therefore, it is not a regular expression. So @b will contain the list of all the files that starts with A to M and ends with .cpp. Or if you don't have the angular brackets, you can say glob, parentheses. It has the same meaning as the angular brackets. So list of all names that match the pattern or empty list if non-matches. So glob 1, so add files contains a list of all the file names that starts with the A to M and followed by anything. So it will match address, letter, not N, because N falls outside of the A to M range, not a sort, because S falls outside of the A to M. So therefore you have the file contains 2 elements in the array, address and letter 1. You print each one. For each, the other file add files. Print each one followed by a new line. So you have address, letter 1. If you have a full path name in your glob, you will get full path name as a result. So it is an absolute path name, starting with etc and /host. It will return all the file names, absolute paths that match etc/host. So you can use substitution to chop off the directory part of the string. So you got the string $file, which is the one file name in the add files array. You match it, equal tilde means match the pattern against this string. Because this is an explicit file explicit variable, you need to use at equal tilde, or if you want to omit it, you need to use a dollar underscore. So this guy says substitute. So the separator is a pound symbol. Remember, you can use any non-alphanumeric character as the separator. We have been using /, but here, because we have // in the pattern, so we use a pound to avoid putting a backslash to escape it. If you want to use / as the separator, you need to escape the / within the pattern. So the / is substituting empty string, null string as the second part to replace the first part, */. So this is saying say you have, for example, this string as the as input string, you delete up to the last slash. That is, you remove everything until the last slash, and only leave the part after the slash. So ** means match anything, any number of times, followed by a slash. And ** is greedy. That it matches for as long as possible. So it won't stop at the first slash. It'll go up until the very last for a slash. And replace this thing with the null string. So as a result, you remove the all the four slashes and anything before that, and only leave the file name. So as a result, you so etc host * matches all the absolute file names. You remove etc / and only leave the host * file name part. Multiple patterns are allowed, so you can say Gates * Clinton * angular brackets. This means match any file that begins with Gates or begins with Clinton. So if this is a directory, -d means checking for if the thing is a directory or a file. If it's a directory, it returns true. You store the string in the where variable. Otherwise, you store Holmes Warner to the where variable. And then you use globbing to place a list of the file names within the where variable directory. So this means expand the where variable into its value, followed by a / followed by a * means globbing. List the file names within the directory and store the list in the file's array variable. And then print it. So variable interpolated means that you actually substitute the value of the variable at $where before you do the globbing. So this says if the directory Holmes Warner 101 exists, then list all the contents of the directory. Otherwise, list the home directory, home folder. So unlink deletes a file just like remove command. Remember that files are just links, hard links in Unix. So typically a file has a single hard link, but sometimes you can create multiple hard links to a single file. So if the file has a single hard link, if you do unlink, it deletes it. If it's has multiple hard links, then the file is still there, but it's in the name of the other link. So print what file to delete. You enter a string. You assign it to what and chomp it, and unlink it. So you enter a file name and unlink, and it is gone. You can unlink multiple files. So because here you don't have the star, you don't need the globbing, therefore you can use parentheses instead of angular brackets. Of course, angular brackets will also work. Here, you use globbing, so you must use angular brackets and .cpp. The star.cpp means that you want to delete any file that ends with .cpp. Return value on unlink is the number of files successfully deleted. So for each file, so this guy, globbing, as a result, it returns an array of variables. If you do a for each, you iterate over the array and assign each one to the scalar variable $file and unlink it. If it's if it's false, false is 0. If unlink is unsuccessful, you print trouble deleting the file. Again, with no arguments, unlink $_ is the default. So we can simply say for each, this line will assign each element of the array of the result of the globbing into $_. And unlink with no argument means unlink $_. And trouble deleting $_. Rename, the same as move in Unix shell. So you rename gates with cheap into cheap. If it's successful, it returns a true. Otherwise, it returns false. Link allows you to create a hard link. So suppose you have a file called gates, and you do this, it means create a hard link called cheap to the file. So now you have a file with two links, both are hard links. One is called gates, one is called cheap. So if it's successful, you say Bill is now also cheap. Otherwise, you say Bill is still only Gates. So soft link, also called symbolic link, you can say sym link in Perl. So this says you have a file called gates. Create a symbolic link called cheap that points to it. So cheap is the link, gates is the file. So cheap is pointing to gates, like a pointer. If you delete gates, then cheap is no longer a valid link. So this line here is really a little bit ambiguous. If you create a symbolic link from gates to cheap, we're saying essentially gates is the actual file, cheap is the link. Don't confuse it. So read link returns the name pointed to by the specified symbolic link. So if you do a symlink gates cheap, then cheap is pointing to gates, and read link follows the link, like dereferencing a pointer. And gets the file name pointed to by cheap, which is gates, and assigns it to a variable. So you can print out the variable name, which is gates. So make and remove directories. Make dir and remove dir, which is the same command as the shell command. Make dir takes the name of the new directory and a mode that determines the permissions. 755 to allow user full permission and no write permission for group and other. So make dir gates dir with the permission 755 or remove dir to remove it. If you recall, permission bits are what is 7 in binary, 111. 5 in binary, 101. 5, 101. So 111 means the user has read, write, execute permission. This is the group has read, no write, and execute. And others has read, no write, and execute. Right, so permission values 0 means no permission. 1 means 001 in binary. The last digit means other. No, the last digit means execute. The middle one is write. The first one is read. So 2 is 010 means write only. 3 is 011 means write execute. 4 is 100, which means read only. 5 is 101, 110, and 111. So the values are octal. That is 8, 9 doesn't make sense. Only 0 to 7 makes sense. And this is for a single group. And you have 3 of these octal numbers to indicate the 3 groups. One is user, one is group, one is other. Leading mode number is always 0. That is, it's 0, 1, 1. So 0, 0, 1, 0, 0. So like this. So Schmott change mode allows you to change file and directory permissions. So you make a directory with 755 as the permission, And I think I said something wrong. So the 0 really means the 0 before the 3 parts, 3 octal numbers. So not in front of each one of the octal numbers. So Schmott 750, and you can also Schmott multiple files in a single command. Process management, you can invoke shell commands. We use burn shell. So by default, in Perl, if you invoke a shell command, it invokes burn shell. Use the system function, system followed by the command name with the argument. So this is the same. You can also do system in C program. So when the command is finished, the system function returns 0 if the command completed successfully, which is really following the C convention. In the C program, if the program is successful, you should return a 0. Otherwise, you return a -1. So here, if it's 0, it means successful execution, which is different from our regular command in Perl, which returns 0 if it fails. Here, 0 indicates success if it's a system call. So if the date returns a non-0, it means it failed, which should never happen because date should always succeed. So the output goes to the display, that is STD out, standard output, unless it is redirected. So here you say system date, it simply prints the date to the STD out. Redirected, you can say angular bracket greater than now. You redirect the output to a file called now. So this is a standard shell command we learned in the first part of the course. So you can put any standard shell command inside of the system call within Perl. It'll invoke this command as the shell command. So if you run it this way, then output is not printed to the STD output, so you don't see anything, but it is stored in the now file. You can do a cat later to look at the file content. So notice if this guy not 0 die. So this command is equivalent to saying if this guy not equal 0. You can omit the not equal 0 part. So you can do multiple commands separated by semicolons on new lines, same as what you can do on the shell prompt. And ampersand indicates background. If you have ampersand, then Perl continues after the system call and does not wait for the job to finish. So it has something after the system call. It'll continue right after it invokes the system call and putting this command in the background. Suppose the command is very time consuming, then it won't delay the lines after the system call. So where is this variable storing the string now, which is a Perl variable? And you say date who. So this is invoking the two commands in sequence. The output of both are redirected into the now file called now. And this whole command is run in the background with the ampersand. After it finishes, this now file will contain these two lines, the outputs of date and who. Also notice that you can omit the parentheses around the quotes. So where is replaced with its value by Perl not in the shell. That is, because we defined the $where in the Perl script with the now variable, with the now value, NOW, this substitution here is the value of the shell variable, of the Perl variable. If you happen to have a shell variable called where, it won't use it. It use the one in the shell script that you defined. So that, which means that where is replaced with its value by Perl, not the shell. If you want to reference a shell variable called where, you need to place a backslash in front of the $sign. So if you happen to have a where, $where defined in the shell, how to define a variable in the shell, we learned it in the first part of the course, right? Different syntax for different shells. For Bourne shell, you just say $where equals something in the shell, not in the Perl. And if you want to reference it within Perl, you need to have a backslash. Of course, if you want to reference it in the shell script, not in the Perl script, you don't need the backslash. So invoke the shell command will inherit the current working directory from the Perl program. Now, if you need a change directory within Perl, chdir within Perl, then and then you do a system followed by a shell command. Then the shell command will work within the directory in the Perl program, not the working directory of the shell where you invoke the Perl program. So, say if you do a change directory within Perl, bunch of directory names, and then you do a system ls star, it'll list the directory of the current directory within Perl. And also the change directory within Perl won't affect the working directory in the shell. So after this command is executed, you come back to the shell, you're still in your old working directory. So how do you look for the string in the file grep, right? We learned this before. Grep followed by a regular expression followed by a file name. So this is the shell command. If you want to invoke it in Perl, then you need to the system allows the first argument to be the command grep, remaining arguments to be the arguments to the command. First argument Bill Gates, second argument Bill. This is the pattern. This is the file name. Back quotes, how do you assign the output of a command to a variable? So backquote means invoke the shell command and assign the output to the variable now. It will contain the result of the date command, including the trailing new line, because you didn't do a chunk. So if you have double quotes, then it'll store the literal DATE in the variable now. Another example, PWD, is the shell command for print the working directory. And you can store it in where current directory is this variable. If the back-quoted command is used in a list context, you get a list of strings. So who returns a list of users. So for this case, you happen to have a single user on the machine. But in general, you may have multiple users logged on simultaneously. So you have multiple lines returned from the who command. So for each, this guy says who invoked the who command. You have the parentheses around it, which means that turn it into a list of elements. So this thing is used in the list context due to the parentheses. Therefore, this thing is a list of strings. Each string is a line as the output of the who. And you use for each to iterate over each element of the list. So $_ now contains each line of the who output. Then you do this. So big S means non-space. Small s means a space tab new line. So big S means non-space. So this is saying let me remind you how this works. So remember, parentheses stores the matched pattern in the variable $1, $2, $3 in the per variable. If you want to use the same value in the regular expression, you use \1, \2. So after this command, then the first parenthesis is stored in $1, second parenthesis is stored in $2. You can also explicitly store these things in a list of variables. So this guy says match a word, store the first match in the variable first, second match in the variable last. So it'll store first variable will store Bill, last variable will store Shakespeare. So coming back to this is saying store the first parentheses match with the who. So this is a non-space. Repeat it multiple times. So this is really equivalent to a big W. That is a word. Wait a minute. It's I think letter digit underscore. No, this is any non-space character, repeat it one or more times. So it'll match Horner. So followed by a space or tab, repeat it one or more times, which matches the whole bunch of spaces here. Followed by another bunch of non-space characters, which is PTS, which is assigned to where, second parentheses, followed by a whole bunch of white space, which matches this bunch of white space in the middle, followed by dot star. That is all the remaining stuff matched to win. So as a result, who now contains Horner, where contains PTS/0, win contains this whole thing, this win. So you can say who on where at win. It'll print out Horner on PTS0 at this string here. So this is win really contains more than the time. It contains also the parentheses CSZ 096, etc. So this is for each line of the output of the who command. So for this example, you happen to have a single line. So you have a single line in the print as output of the print. If you have multiple lines, it's for each will iterate over each line and print out each line in turn. So processes, you can run a shell command with open, close, and print. If you open some special files, so open file is the handle. By convention, we use uppercase letters for indicating file handles, but you don't have to, it's just convention. Open this file for reading. Assign the contents of the file, read it into the array variable at letter. Now close it. Now this array variable email list contains these two emails. QW means grab the list of strings in the parentheses and assign it to the variable email list. For each email in the email list array variable, open file handle mail. Now this is a special syntax. So this is supposed to have a file name following the file handle as the second parameter to the open call. But you have pipe, you have vertical line mail. This is saying that open a special file handle, but it's not really a file. This is really anything you put in the handle will get piped into the command. So anything you print, say you print mail hi email, which is the email address, either corner at CS or corner at UST, and you print letter, which is content of the file letter 1, and then you close it. So if it's a regular file, this whole thing will be written from hi email to letter content will be written to a file called mail. But you're not really writing to a file, you're piping it, piping the output of this thing into mail command. With the subject -s hi email. So with the backwards to escape the quote indicating you want a real quote in the subject. The -s is this mail's command argument indicating the subject of the mail followed by the body of the mail. So as a result, it'll send a email with the subject, hi, email address, and body as hi, email address, content of letter 1 file. So another example, same letter 1 array variable contains a list of strings with the content of file letter 1. Open print is a file handle. You pipe the output to an LPR, which is the print command on Unix line printer. -p is the printer name. CLL2A is the printer's name. What do you print? You print hi name. Name is the each of the Andrew, Bill, and Bob, and followed by the array variable letter, which contains the content of the file letter 1, and then finally you close it. So it is clear. This is just use the pipe command in shell to redirect the output of your print to the command instead of to a file. And close will send the end of file to the input, so that it'll know, this command will know when to finish the first part and redirect the output to the second part. So now we have some quiz questions. So this is a really quiz for functions, file I/O, and directory access all together. So kind of a review of the previous few classes. So what output is this? I'll give you a few minutes to work on it. So this is the function call with the subroutine test, passing it 3 arguments, 1, 2, 3, CDA. Now, how do you refer to the arguments within the function call, within the subroutine? Add underscore. That's the array variable containing the arguments. My means that local variables, all these variables here are local variables within the subroutine. So now C is assigned 1, B is 2, A is 3. Now B gets 3 after this line, and when you print it, you print 3, 3, 1. Right, 3, 3, 1. And then after the subroutine call, you have another print in the main body of the program, which prints out 3, 2, 1. So the key is that my creates local copies of the variables. Therefore, the CDA within the subroutine are different variables from the global variables ABC. And they don't interfere. Therefore, modifying the local variables do not modify the global ones. If you didn't have the mind here, you would modify the global variables, which is not a good practice.
So it will make it like pass by value.
Yes. If you have the my here, it's really passing by value. If you didn't have the my, well, if you do the assignment this way, it's passing by pointer, but you can assign it to different variables. This one is supposed to print out maximum of 2 numbers. What is wrong with this? use strict. Use strict forces all variables to require declaration with my. Therefore, if you have use strict, then every variable must have my, including the one in the main body of the program. This is to avoid inadvertently sharing variables where you shouldn't. So, therefore, if you have my $A, my $B, my $max. And also there's a small mistake here. Add underscore is the list of input arguments, not $underscore. $underscore is the default variable to use where if you don't specify the variable name, which is not appropriate here. This one is supposed to copy a file to another. What is wrong with this? So you open the first file, in file, for reading, open the next one for writing. If you want to open the file for writing, you must have greater than to indicate it is for writing. Well, in print. So this doesn't print to out. It prints to standard input. So you say print out, which means print to the output file handle, or print out $underscore, which can be omitted. So, and it should have angular brackets around the end, which means that the content of the in file, read the content of the in file one line at a time, assign each line to $underscore, and print it to the out file handle. So look at what's wrong with this program. If a in file exists, die. This is right. If the file exists, then you die.
If the alpha will succeed.
Yeah, if the alpha exists, then you die. Yeah, this one is wrong. And if open file unsuccessful, then you die. So here you should say unless, if not, because open will return a true if it's successful, unlike system, which returns a 0 if successful. Open returns a true non-zero if it's successful. So unless open, then die. Open out or die. So this is if this one is false, then you'll die. Otherwise, you don't die. So it shouldn't be and. It should be or. And while input print out, so this is fine. Close in, close out. Schmod. So this should be schmod 0700 comma $A. This is the curve syntax for schmod. If it's shell script, you don't have the comma. So change directory. What's wrong with this? So if scheduler is successful, you should say succeeded. Otherwise, it failed. So remember that only when you have system parentheses, then it's backwards, right? System call returns 0 when successful, non-zero otherwise. But if you don't have the system there, it is if it's successful, it returns non-zero. Unsuccessful returns a 0. So if you said system parentheses double quotes scheduler, then it's backwards. But here you should say it's if successful, then you put succeeded. So remember, scheduler is both a shell command and a per keyword. So you can use it both ways. You can use it as a per keyword and say scheduler within the per script, or you can say system parentheses scheduler, which will invoke the shell command scheduler. These two are different things, even though they may do the same thing. And they have different return values. Per command scheduler, per keyword scheduler returns a non-zero upon success, while the system command evoking the shell command scheduler will return a 0 upon success. So this one deletes all the files in the current directory. What is wrong? This is really a simple syntax question. So you should surround this guy with the parentheses because you use it in for each. So this is globbing, right, with the angular bracket. And then what you want is to use it in a list context. So if you use the result of the globbing, surround it with parentheses, you are using it in a list context. It returns a list variable, list of elements. So you want to do for each, which means that this scalar variable is assigned to each element of the array of the list. So you must surround it with parentheses and unlink it, delete it. Or you can omit the variable name, then you use double underscore as the default variable, and it'll also work. Okay, that's all I have for today. So, see you next time.